Welcome, viewers. You know that I have started relative motion the other day. You must have gone through the video. Remember, every time I need not have to tell you, but I am forced to remind you that if you want to follow any of these things, the previous lectures must necessarily be looked into. For that reason, it is better that you subscribe these videos. So that whichever you want, whichever is useful, you can display it. All right. Now, this is relative motion. I already defined what is relative motion, right from position, relative velocity. Then I have looked at relative acceleration, and along 1D we did some models the other day. How to catch the bus, and if the person starts accelerating, etc. Now, in the same vein, I'm going to give you another problem. I'll take it as a station A, and this is station B, and here one bus leaves every delta t1 time, maybe 10 minutes, 15 minutes, 20 minutes, 30 minutes. Okay, I'll give you every 10 minutes a bus leaves, and the bus constantly moves with 60 kilometers per hour. Okay. Now, the distance between A and B is along a straight unidirectional path, and the distance between these two, let it be 60 kilometers. 60 kilometers. Now, every 10 minutes one bus leaves from here and reaches B. So, at one instant, a car leaves here. Car moves with 90 kilometers per hour constant speed. I want you to follow this carefully. Every 10 minutes one bus leaves A and reaches B. And there are so many buses now, say likewise. These are all at one instant. When the bus arrives, and a bus is about to leave. This condition is important. When a bus is just arriving B, and then another bus is just about to leave A, at that instant, car leaves with 90 kilometers per hour. Now, by the time car reaches B, how many buses does it overtake? This is the question. How many buses does it overtake? This is the question. Okay? Now, how to make use of the relative velocity concept here? Now, the car is here, the one bus is here. Bus is moving with 60. Car is moving with 90, and every 10 minutes you said. 10 minutes means how far this bus must have gone from the starting point, 1/6 of the time, right? So every minute it goes 1 kilometer. Every 10 minutes, therefore, it is 10 kilometers. Now, here is a point. Here is distance 10 kilometers. This is the bus. This is the car. The same thing I am reproducing here. So bus is going with 60, car is going with 90. What is the relative velocity of the car with respect to bus? 90 minus 60, because they are in the same direction. So the relative velocity of car with respect to bus is 30 kilometers per hour. What is the relative distance? Initially 10. When it crosses 0, so relative distance is 10 kilometers. What time it takes to overtake one bus? So T is how much? How do you ever come? T is equal to SR by velocity. Remember, this is in kilometers, this is in kilometers per hour. Therefore, this is 1/3 of an hour. I hope this is clear to you. What do you mean by that? The bus is about to leave, car is leaving, there is another bus which is just a 10-kilometer distance, but that is going away with 60. This is rushing towards that with 90. Relative speed is 30. If it is going 30, how much does it cover in 10 kilometers relative? So you take 10 by 30, 1/3 of an hour. That is fine. I hope this is clear. To overtake one bus, it takes 1/3 of an hour. Okay? What time car takes to reach B? What is the total distance? You have already written 60 kilometers. So the speed of car is 90. So the time taken by car from A to B. How much? 60 kilometers by 90. So it will hardly take 2/3 of an hour. 2/3 of an hour. What do you mean by that? If it reaches here 2/3, every 1/3 it is overtaking one bus. That means first 1/3 of an hour, though it may be it overtakes one bus, right? 2/3 means it is reaching. At that instant, it is the bus is arriving, car is arriving, therefore we don't call it as overtaking. So effectively, this car actually overtakes only one bus, because in 2/3 of an hour total time, every 1/3. So divide 2/3 by 1/3, you will get 2. What is it?